Guys, back with another video. Thought I'd break down a good meta-analysis that y'all might be interested in. It's about the myth that soy, eating soy can somehow impact your testosterone levels. So I'm looking at a meta-analysis. I think it's Reed et al. 2021. It's called, I think, neither soy nor isoflavone intake affects male reproductive hormones. An expanded and updated meta-analysis of clinical trials. I believe that's what it's called. So again, it's a meta-analysis of randomized controlled trials, so it's not just one single study. It's a summation of all the studies on the relevant topic, which is good because it prevents cherry picking of, studies leaning just one way or the other. So it gives you an unbiased consensus of the data, which is kind of the whole purpose of science, obviously. To cut to the chase, I think there were about 38 total individual randomized controlled trials or individual studies analyzed in this meta-analysis, and basically it showed that I think consuming 70 grams or less of soy protein and I believe 75 milligrams or less of soy isoflavones per day or something like that did not impact total testosterone, free testosterone, sex hormone binding globulin, E2 and E1, which I think are estrone and estradiol respectively, I think. But again, it doesn't affect E2, E1, total testosterone, free testosterone, SHBG. None of those reach statistical significance, and probably not really practically significant either. So um, we can kind of go over both the theoretical and the practical side of this. So theoretically, from like a biochemical perspective, this doesn't surprise me one bit. In order for the body to deviate from homeostasis, meaning have like some kind of metabolite either really just start accumulating or get depleted, you would probably need to have some kind of maybe inborn error of metabolism, or either eat absolutely humongous amounts of some kind of food or whatever, or completely deplete your diet of it. But again, I believe these people ate 70 or less grams, or 70 was like a benchmark of something, so like up to 70 grams of soy protein per day, I think. And I believe it was up to 75 milligrams or milligrams per kilogram of isoflavones per day. So these are very like practical and realistic dosages of soy protein and isoflavones as well. And once again, E2, E1, testosterone, total and free, and SHBG didn't change. So mechanistically, this makes sense because I think, as I said before, to get away from homeostasis from a biological perspective, you have to be exposed in huge doses in order for the body to leave homeostasis. So again, on a more mechanistic level, when you let's just take testosterone for example, because everyone in the fitness space, they love to talk about how when you take anabolic steroids you make less testosterone naturally, but they don't mention that for estrogens. The truth is that this can practically apply to any kind of metabolite. Like, for example, if you eat non-essential amino acids, your body just doesn't need to make them. If you eat a lot of carbs, gluconeogenesis is going to slow down. So this can apply to pretty much any metabolite. And I'm sure, as y'all know, if you take steroids, your body's going to make less testosterone on its own. And I'm not aware of any data that that is the exact mechanism when it comes to like consuming estrogens or soy protein, but I wouldn't be surprised if that's a mechanism. Or you could potentially just be excreting more of it. So, for example, if you take testosterone, there's going to be more testosterone in your urine, and I'm sure that's probably the case with estrogens too. So, estrogens can decrease the rate of expression of a bunch of enzymes that are responsible for their own synthesis. It's kind of the same deal with testosterone. I believe testosterone, through some mechanism or the other, it inhibits, I believe, luteinizing hormone and/or gonadotropin releasing hormone. So then you synthesize fewer of these steroidogenic enzymes that make testosterone. And you can apply the same to like cholesterol, for example. So cholesterol, it allosterically inhibits an enzyme called HMG-CoA reductase, which is responsible for the synthesis of cholesterol. Um, there's some mechanistic research. I think it's from 1998, suggesting that if you eat more cholesterol, you make less cholesterol within your body, which again just makes sense. And again, I'm sure you could probably apply this to estrogens. If you consume a lot of estrogen, you'll, probably make less estrogen within your body. So that's going to kind of give you these normal levels, which is supported by the data from this meta-analysis. So on a theoretical level, it makes sense that you'd make, less estrogen just by producing less, and you'd also probably excrete more of it if you were to, you know, consume a lot of estrogen. So this just makes pretty simple sense from a biochemical standpoint. Now, I'm not telling you that you should like intentionally eat soy. I think it might be a good idea for vegans because obviously you're kind of limited in terms of where you can get your protein from. And if you want to avoid soy just to be safe, then that's totally fine. I'm not here to tell you what to do. I'm just telling you what the science says. And again, science just reports the averages. It doesn't tell you what one person's going to get or the other person's going to get because people can obviously deviate from the average one way or the other. So overall, on the average, it seems like eating soy is not gonna, make you grow man boobs or anything like that. So on a practical level, soy can be really useful for vegans to consume as a source of protein. If you want plant protein and you do want to avoid estrogens, which there's nothing wrong with doing because again it's your choice. There's obviously pea protein, rice protein, and I think probably potato protein and corn protein too. If I recall correctly, corn actually has a pretty good chunk of leucine in it. I think it's probably comparable to whey. Leucine, if you've kind of been in the fitness industry long enough, you probably know that leucine's kind of unique to other amino acids in terms of how it regulates protein synthesis, which I could get into on a whole separate video, just to get a little bit into the mechanism behind it. There's mechanistic research suggesting that leucine can bind to a protein called cestrin 2, and then that alters how cestrin 2 can bind to further downstream proteins. Then that affects the activity of the protein that y'all have probably heard of, which is mTOR complex 1. And then that can affect the activity of eukaryotic elongation factors and initiation factors in protein synthesis. So again, if you want to avoid soy, but you want to get a good plant protein source, corn's probably good. On the other hand, if you're vegan or vegetarian, you could probably get away with just eating a lot of protein. So to kind of get into the mechanism of why animal protein is generally better, especially when your total intake is lacking, is because as y'all probably know, animal protein has good amounts of all the essential amino acids, and amino acids are the reactants in the chemical reaction of muscle protein synthesis. Just like any generic chemical reaction, if one reaction is limiting, it doesn't matter how many you have of the excess. This is like making cheeseburgers and you have an excess of everything, but you have no cheese. You can't make a cheeseburger because you're just completely limiting with one of the ingredients, and that can apply to protein synthesis and any chemical reaction. So as this all applies to eating plant protein, um, a lot of plant proteins they tend to be limited in I believe like methionine, leucine, and lysine if I recall correctly. So they end up being limiting reactants for protein synthesis. And a way that you can overcome that is just eat more plant protein. So just due to sheer quantity, you'll have more of the amino acids. Or you could obviously kind of mix up different proteins if you want to be vegan but you don't want to eat a crap load of protein every day but still make gains. You can obviously mix up different plant proteins. And again, as this data says, if you consume soy in a moderate amount, again I believe it was like 70 or less grams of soy protein per day, you probably won't impact your testosterone, estradiol, or SHBG levels. And then as it relates to being a source of protein, I believe there was another meta-analysis. I think it came out either this year, 2021, or 2020, but it was pretty recent, and it showed if you consume at least 1.6 grams per kilo of protein per day, animal and plant protein are pretty much good enough. It's when your total protein intake is lagging, that's when quality starts to really matter. On the other hand, if quantity is really high, you're just consuming so many of the amino acids overall that quality you can kind of get away with a bit less. So the practical implication of this is that you probably don't need to avoid soy like the plague. I'm not telling you to eat soy. If you want to avoid it, then that's obviously up to you. Um, but once again, you don't need to avoid it like the plague. And it can be a pretty good source of plant protein. I think some nutritionists might consider it, a complete protein because it has a good chunk of all the proteinogenic amino acids. So it can be a good option if you consume it in moderation. Outside of that, obviously you can consume pea protein, rice protein, potato protein, and a bunch of other plant proteins. So hope this was helpful. Subscribe. I'm probably gonna make a bunch of new videos over the next few weeks, and gonna keep them coming. See y'all later.